Alright guys, so section 1.8 is a little bit different because it's got like a ton of different stuff paired with it. Okay, the goal for section 1.8 is we just want to throw a bunch of different ugly looking equations at you guys. Now, some of these types of equations you guys have seen before, and then some of them might look completely different. Okay, so the stuff is pretty complicated. We're not going to get really in depth with this stuff until like Algebra 2 for you guys. But the principle we want to start talking about is we can really graph anything we want if we just have the input-output table for it. If we were able to get some points and like plot the coordinates, we can still make a graph of any type of equation regardless of how ugly it is. Okay, so for these examples, it says a bunch of different stuff. It says first, graph each function rule and name each function by its correct mathematical name. Okay, we'll talk about the names of these ugly looking equations in a second. And then it says after that, state the domain, the range, increasing intervals, decreasing intervals, x and y intercepts, and any symmetry that you observe. Okay, so a ton of different stuffs. So let's start off by making this a little bit more manageable. I don't want to throw too much at you guys. Let's not worry about increasing intervals, decreasing intervals, and symmetry just yet. We'll talk about all the other stuff though. Okay, but we'll start with an equation in the format of something we have seen before. Number one, it says graph y is equal to negative 1/2 x minus 1. Okay, so this equation follows the format y equals mx plus b. M is equal to negative 1/2 and b is equal to negative 1. Okay, so we have seen something like this before, and what we might remember from chapter 3 and 4 is anytime we have an equation that follows this format, it's going to be a straight line. Okay, anytime we have an equation that's a straight line, we call it a linear equation. That is the mathematical name for this thing. If it's in the format y equals mx plus b, it's a linear equation. Okay, so now what we're going to do is we're going to try to graph this thing. And if you guys remember how to graph lines, you always start at the y-intercept. In this case, it's negative 1. So I start in the middle and I go 1 unit down, which is right here. Okay, then I use my slope, which is my m value, to get my next several points. So it's always rise or run. What I'll do is I'll start at my y-intercept and then I go down 1 over 2, 1, 2. Down 1 over 2 to the right, 1, 2. I can keep doing this process over and over again. Down 1 over 2. I'll have a bunch of different points, and I can also go in the opposite direction. If I wanted to get some points to the left, what I would do is instead of going down 1 over 2 to the right, I could do the exact opposite and go up 1 over 2 to the left. Up 1 over 2 to the left, same thing over and over again. Okay, and then once you have this, once you have a bunch of points, you can play connect the dots, and your equation should look something like this. And this line should extend all the way through. Okay, so it's a straight line, nothing we haven't seen before. But let's break this down a little bit further and talk about some of these key things. Okay, so we introduced these words of domain and range in the last section. And remember, what I told you is this. Anytime you see the word domain, I want you to think x. Okay, so when you see the word domain, just think, what am I legally allowed to plug in for x? Okay, so when we get further and further along, you're going to start seeing ugly equations with these things called domain restrictions. Okay, that means you can't plug in necessarily any number you want. Okay, but with these basic types of equations, like linear functions, my domain is going to be what we call all reals. Okay, all that means is I can plug in any number I want into this equation for x. Okay, there are no sort of restrictions. There's nothing that's illegal to plug in. I can plug in negative a million, I could plug in positive a million, I could plug in 0. I could plug in any number I want into this equation. So my domain is all reals. Okay, and then we also talked about range, and range is the y values. Okay, when you think range, think what values can I get back? Okay, so here's how I always tell what the range is. The range is how high or how low the graph goes. Okay, so what we notice here is if we look at this line, it does like go up forever and ever if we look further and further to the left. I'm going to get every positive y value I want if I just keep extending this line further and further. It's going to keep going up forever and ever, so I'm going to get all my really, really big y values at some point. Okay, but in the opposite direction, it also goes down forever and ever. I'm going to get every negative y value that I could ever want. It goes down all the way to negative infinity, and it also goes up to negative infinity. Okay, because I can ultimately get back any y value that I want, my range is also going to be all reals. Okay, these become a little bit tricky when we have more complex functions, but for right now, all reals for domain and range tends to be the most common response. Okay, next two things we see are x and the y-intercepts. Let me change my color here. So the x-intercept, or well, let's start with y-intercept. We have seen y-intercept before. Remember, y-intercept is where the graph crosses the y-axis. Remember, the y-axis is the one that goes up and down. So we ask ourselves, okay, where does this graph cross the y-axis? It crosses right here at this point. Okay, so your y-intercept, you just ask yourself, okay, what is that number? It's 1 unit down, so my y-intercept should be -1. And the x-intercept is basically the exact same concept, but instead of where it crosses the y-axis, the x-intercept is where it crosses the x-axis. So I look at my graph and I see where does this line cross the x-axis. I pay more attention to the dots rather than the line. It looks like it's crossing right at here. Okay, 2 units to the left, which would be -2. This line will cross the x-axis at -2. That is my x-intercept. Okay, and let's not worry about increasing interval, decreasing interval, and symmetry right now. Okay, so these are the 4 things I'd like you to fill out for right now. Okay, we're going to come back to number 2. Let's do one that we might have seen before. Okay, so we have graphed something like number 5. This is called an exponential function. This thing follows the format y equals a times b raised to the x power. Okay, that was what we did in chapter 7. So we have made these graphs before, and the way we made them was by using that graphing calculator and making the input-output table. Okay, so let's start with the mathematical name for this. There's 2 things you could call this. This is called, more precisely, an exponential function. Why is it called an exponential function? Because there's a variable in the exponent. Okay, but I guess a little bit less precisely is this is a non-linear function. Why is it non-linear? Because this thing is not going to look like a straight line. Okay, so when you guys are at home and you don't have access to a graphing calculator, Desmos can be super, super useful for you. So what you can do is if you type in Desmos graphing calculator, you can type in this equation exactly as you see it on your sheet, and you'll get a graph for it. Y is equal to 2 to the x power. And it looks familiar. It's that graph that starts off super low and then all of a sudden spikes towards the ceiling. Okay, but you can use this graph to get some points on your grid when you ultimately graph it. Okay, so the first point I see here that I know I'm going to have is 0, 1. I know that 0, 1 is going to be one of the points on my graph. I can plot it right here. Okay, let's see. When we plug in 1 to this equation, what do we get back? It looks like I have 1, 2 as one of the points on my graph. I can also plot that. 1 to the right, 2 up. Let's get 1 more going to the right. If I plug in 2, what do I get back? I gotta zoom out a little bit. When I plug in 2 into this equation, I should get about 4 back as well. 2, 4 is another point. Okay, so I got 3 points going to the right. Let's get a few more going to the left. Let's see if I plug in -1, what do I get back? If I plug in -1, tough to be precise, but it looks like when you plug in -1, you get about 0.5 back, so I can plot that as well. 1 unit to the left, and then 0.5 units up, so half a unit up. And then when you plug in -2, it should give you 1/4. But you can use a graphing calculator or keep going back to that Decimal graphing function that they give you using the technology. Okay, but you know your graph is going to look something like this, and when you ultimately plot it and connect the dots, you should have that nice exponential curve where it dances above the x-axis the entire time, but never crosses it, and then spikes towards the sky on the right side. Okay, so we have made these graphs before. We should be decently familiar with it. Okay, but let's talk about the domain and range. Remember, ignore these two, at least one. So domain and range. Remember, domain is anything you can plug in for x. Okay, so right now, with this function, the way it's written, I can plug in any number for x that I want. I could plug in negative numbers, I could plug in positive numbers, I could plug in 0. There are no domain restrictions, so I'll call this all reals. Okay, but remember, range is what you can get back for y. So this one's a little bit different because we notice that there is like a floor to this one. There's never a point where this graph goes below this dotted line. Okay, I never get negative y values. Okay, it always stays above 0. Okay, I can get any positive y value I want. The thing does go up forever and ever, but it never goes below 0. Okay, and if range is all the possible y values you can get back, the way you say what your range is y needs to be greater than 0. I can get back any positive y value, I just can't go negative, and I can't get exactly 0. Okay, the x and the y-intercepts. Last two things. So the x-intercept is where it crosses the x-axis. Well, we just talked about how this thing is actually never going to get below that dotted blue line. It's never going to cross it. So my x-intercept, it never actually crosses this axis, so I just say there's none. But it does cross the y-axis. It does cross my vertical up and down line. It crosses right here, and I ask myself, what's that point? Looks like it's 1 unit up. My y-intercept is 1.